This is the second e-learning assignment for geometry in the spring of 2020, in which we're going to work on pages 19 and 20 in your note packet. Now, the screen I have up on the board is not the same as the page in your note packet. Your note packet looks like this instead. There's a limited number of problems. I'd like to get you guys to do those problems. So I'm going to do the problems involving this picture instead. The calculations we're going to do should be fairly simple. You've seen this before in grade school. We're just going to find the area of a circle using this formula, pi r squared, and we're going to find the circumference of a circle using this formula, 2 pi r, both of which you should have done at some point in the past. There is going to be one extra small trick that we run into on this page in the note packet. Okay, the first thing you should know is in this picture we're given the measurement from the center of the circle right here to this side of the circle. That's called the radius. And the radius is the measurement we want to use for our calculations. Sometimes instead you're given the diameter. Diameter is the distance all the way across the circle, still through the middle, so the middle is still here, but it's a measurement all the way across the circle. If you're given the diameter, no problem. The diameter is always twice the radius. So if I have this measurement as 16, then I'm simply going to take half of it to find the radius, in this case 8, which is the measurement I want to use because both my formulas here are using r for radius. So the basic questions we're going to start with is calculate the area, calculate the circumference. They're both very simple. We're simply going to take the measurement for this radius, and to find the area, I'm going to plug it in for r in the area formula here. To find the circumference, I'm going to plug it into the formula for the circumference. So my formula for area, instead of pi times r squared, is now pi times 8 squared. We just plugged 8 in. Now, if you do this normally in your calculator, you can just type this all in at once. You should know that your calculator has a pi button that gives you a very accurate estimate for pi, 3.1415926 something or other, and it keeps going. For this class, I'm just going to use 3.14 for every value of pi. If you use the pi button, your answers will be slightly different from mine, but not by much. The reason I'm doing that is that's what the SAT always does, so I'm going to do the same thing. So the rest of this problem for finding the area is simply in the calculator. I'm going to type in 3.14 times 8 to the second power, and it's just going to give me a value for my answer here. And in this case, I'm going to get 200.96. That's the area of this circle. If you've forgotten what area is, that's just how many little squares fit inside this circle, how much flat space this circle takes up. To do the circumference, well, first off, if you're not familiar with the word circumference, circumference is what we use instead of perimeter when we talk about circles, because we talk about perimeter as being the sum of all the sides, what we get when we add up all the sides, but a circle doesn't really have sides. So when we talk about the distance around a circle, we got to give it a different name, and that name is circumference. So this distance around the outside of it, that's what we're calculating for circumference. But we do it the same way. We're just going to take 8, plug it in here. It's going to be 2 times 3.14 times 8. And the rest of this problem is a calculator problem. We simply multiply that in our calculator, and we get 50.24 for our circumference. Notice, by the way, that the measurement for area is in square meters. That's our units, because it's how many squares fit inside. But 50.24 is just in meters. It's just a distance. How far do you have to go around the circle? So now here's what's actually different for this class from what you've probably seen before. Depending on what value someone might use for pi, this answer is not exactly right. I used 3.14, which isn't the best possible answer. If I actually use the pi button in the calculator, it would give me 2 times a much more accurate version of pi. It actually ended up getting 50.265. I'm off by, 2 100ths, which doesn't seem that much, but it does make a difference. These answers here that we got using the value 3.14 for pi are wrong. You might say, okay, so we should use the pi button on the calculator. Well, that answer is still rounded off at some point too. So what we want to be able to do is give the exact answer. And that's the way we don't have to worry about having made any rounding errors. The exact answer is easier. All we do is we actually just don't multiply it by pi. For example, in this first problem, instead of doing 3.14 times 8 squared, I'm going to do the 8 squared here, which gives me 64. And now I still got to multiply by pi. But instead of multiplying by pi, I just say multiply this by pi, and I stop there. 64 pi is what's called the exact answer. All we did is not multiply by 3.14 or use the pi button, but we just stopped and said, take this number and multiply it by pi. That is what's called the exact answer. We can do the same thing with circumference. Instead of multiplying by this 3.14, I'm going to replace it with the pi symbol. And we're multiplying 2 times pi times 8. But we're not going to actually multiply by pi. We'll just do 2 times 8 and say we should multiply that by pi. Well, 2 times 8 is 16. And what's 16 times pi? It's 16 pi. And we just stop right there and leave our answer as some number times pi. You multiply all the normal numbers that you can, and then just say times pi. Leave your answer like this. These are our exact answer. On page 19 in the note packet, the formulas are given to you. They're listed up here. You can use them. But we're going to need to practice finding exact answers for these problems. So we're going to leave things in terms of pi. So this first problem here, problem number 1, find the exact values. So your answer is going to say something like 10 pi or 30 pi. For the second problem, we're finding area again, and it's exact. But in this case, I'm given the diameter, so you're going to cut it in half to use the radius. And leave your answer as 7 pi or 50 pi. Down the bottom, same thing. Plug these into our circumference formula. We're still doing exact values. Your answers will be 12 pi or 30 pi. And then again, in this last section here, we're not doing the exact values. In this case, it says use 3.14. So in this case, you're actually going to use the decimal 3.14 and multiply them out. Keep in mind, in these problems, you're given the diameter again, so you have to take that measurement and cut it in half and then use that value. So you should now be able to finish page 19 in the notepad. Next, we're going to talk about how to do page 20. Page 20 is actually significantly easier. It's more of a concept here that we'll work on next week. Starting off, we're told we're going to have a pizza, and its diameter is 12, so you should know you need to use the radius 6 to calculate stuff. You can use the approximate answer for all the problems on this page. In other words, use a decimal. Actually multiply by 3.14. When you get this pizza, you're going to have something like 113 or so for your area. And then we're going to cut up the pizza. We're not talking about a whole circle here. The whole point of this page is we're talking about slices. Just one slice of pizza. That's what the focus is going to be on. Now, a few things you probably need to know. In math, we don't have an actual definition for the word slice, but we have a word that describes this shape. We call this a sector. So when you're asked to find the definition for a sector, it just means a slice. You can get an official definition online if you want, but a sector is a slice. And you'll be asked in our next assignment to find the area of a slice, which we'll call sector area. The other thing you'll be asked to define is arc length. Arc length is just the part of the circumference that we have here. In other words, if I just want to know how long is this part of the circumference of the circle, or in other words, how much crust do I have in this slice of pizza? So arc length is just the length of the arc of the circle, or a part of the circumference. So the idea for these problems is actually really simple. You find the area of the whole pizza in problem number 1, and number 2, it says we're going to cut it up into 4 equal slices. So we're just going to divide it up by 4. And then instead of talking about the area in square inches, here we're going to talk about it as degrees, which is how we measure parts of a circle. If the whole thing is 360, how many degrees of the circle is one slice? Well, if we cut it up into 4 slices, we can just take 360 and divide it by 4. And then in problem number 6, we're doing the same thing, except now we're cutting up into 8 slices, and we're simply dividing by 8. Down here on the bottom, some people have a little bit of confusion. 8 and 9 should be easy, but some people overthink problems 10 and 11. And what I'm asking about is this picture over here. What's the biggest slice? What's the smallest slice? And what you should notice about these problems is that as one of them gets bigger, the other one gets smaller by the same amount. In other words, if you don't cut it evenly, if you make one piece twice as big, if you make one piece have an extra 10 degrees, then the piece next to it will have 10 degrees less. Okay, that should be all you need to complete page 20 of the note packet and complete the second e-learning assignment for geometry.